Hi, dear students. This video record is about dimensioning, but not on dimensioning format, not on size tolerances. Already studied on such things, you know. This video is about the things to do in CAD environment. First, in AutoCAD. In AutoCAD, what is the thing or what are the things to do for showing the dimensions of the object, necessary dimensions of the object? In civil engineering, architectural applications, the object is house or building or skyscraper. But in civil engineering, well, house, building, not only house and building, but also, well, dam wall, for instance, dam construction, roof construction, tower construction, platforms, and railroads, and, road lanes. But in mechanical engineering applications, the mechanical engineering product, you know, maybe automobile, aircraft, ocean liner, cutting tools, machines, any mechanism, any machine. Since in this course, Mech 113, this is the course, you know, for mechanical, chemical, aerospace, petroleum engineering students in our university, in our campus, Northern Cyprus campus. But in short, say that except civil engineering program and the students, all the other engineering branches, Mech 113 is the course code in our curriculum. Civil engineering students, well, for few years, the course code is different and the content, mainly the same that of Mech 113, but say some topics, some chapters are special for the interest of civil engineering students. In civil engineering application, yes, not this video record mainly, but in other video record, I'm going to, demonstrate if the object is a building, a house, and say the drawing is say that plan view, then how the dimensions are shown. Specifically, there will be a classwork demo for the interest of civil engineering students. Although it is so, at the beginning of this video record, drawing a rectangle and saying that assume it is the plan view of a building or a house, then quickly deliver a few sentences. One more time to make an underlining on the main difference between, say, civil engineering applications and the other engineering branches, the application in the other engineering branches. Okay, this video record, repeat again one more time, is to demonstrate the things for showing the dimensions, okay, on the necessary views of an object. These are needed to describe the shape, and say after adding the dimensions using the dimensioning format, obeying to the all of the dimensioning rules, then that drawing sheet will be engineering drawing sheet. The sheet reader can find the information not only on the shape of the object, but also on its size, thanks to the indicated dimensions. How the dimensions are shown? First, answer the question in AutoCAD. And next video record, I'm going to answer the question while selecting the other software inventor. Okay, for civil engineering students, last 2 weeks of the semester, the software will be not AutoCAD, not Inventor, but Autodesk Revit. last week of the semester I'm going to answer the question under dimensioning title, how the dimensions are shown, or what are the things to do to show the dimensions in Revit. Okay, let me start. In my demonstration, for the interest of not civil engineering students, but say, the other engineering branches, the students in the other engineering programs, I'm going to use this object, the model of the object. Say here it is in inventory environment. For this object, okay, I'm going to demonstrate. Well, although the things going to be demonstrated for this object on its projections, but the things are in general, not specific or special, only applicable or valid for this object. It is just an example. I selected this object as an example, and on its views I am going to show the dimensions. Well, the things to do at the configuration stage and also thereafter the showing stage, not specific for this object. These are all in general applicable for any object, the drawings of anyone. Okay. Since the first software, this video record, the software to find the answer of the questions, how the dimensions are shown, what are the things to do, is AutoCAD, then say that object is this one, the model is in inventory environment, but in AutoCAD environment I have the drawings of this object already drafted. That file is in the memory of my computer, and then just about to open it. Here it is, the file. Yes, in the file I have the orthographic views. Here these views, by the way, say not created, drafted views. For few years in AutoCAD it is possible to create the solid model of something, solid model of an object. Well, it is the method of today. Create the solid model, and then using the tools of software. In AutoCAD, tools of AutoCAD. In Inventor, tools of Inventor. Create the views. If there is a solid model at the background, okay, created in AutoCAD, okay, then using the layout environment can create the views. Okay, can create the views. But here in this example, these are not created views. These are drafted views. Enable you to see the background, asking the visibility of the layer in which I have the transfer lines. Yes, started from the transfer lining stage. Okay, after marking the projections of the characteristic points, which points? The points, characteristic points. For instance, one of them, center of this edge. It is the edge of semi-cylindrical channel at the bottom side of the object. By the way, I'm going to say that this is the front side, okay, and this is the top side. So the other principal side, primary principal side, here is the left side of the object. Okay, this surface is the most left surface, and this surface is the most front surface. Okay, in the geometry of the object, what we have here, we have an oblique surface. Okay, after saying that this is front, this is left, this is top side, then this is going to be inclined with respect to all the picture planes, principal picture planes. So it is an oblique surface. You know how an oblique surface can be created. In AutoCAD, in Inventor, already answered this question. You can find the lecture notes about oblique surfaces and then make a review. The main part of the object you see is a right prismatic part. The base of the object has here a counter bore hole. Yes, see the combined and single features of the object. Then much more easily can understand while I'm showing the dimensions. The dimension is the size of which feature. That's why at the beginning, well, using such a time, trying to introduce the object. Okay. Well, at the base of the object, yes, it has an oblique surface, bottom side semi-cylindrical channel. It is extending from the front side to the back side. Okay, well, the right side of the base is a semi-cylinder. This is a semi-cylindrical surface. Okay, and this is a contour bore hole. Well, truly extending contour bore hole. Well, at the top of the base, we have such a prismatic feature, combined feature with such a step. Okay, and two semi-cylindrical extensions. Within the semi-cylindrical extensions, we have truly extending holes, this and that. And to be able to make this intersection more strong, okay, well, against the forces, those well, will be applied by the surroundings of this object. Well, such a strengthening flag has been added. Rip, it is called rip, you know. We have triangular prismatic support here. It is to increase the rigidity, strength of this interior edge. That is the object, that's it is geometry. Well, in Inventor, you know, creating the model of something, you know, we start from here, new file creation, and then here selecting in this pane, in the dialog box from this pane, metric option, then Inventor can understand that we selected millimeter. And then select this template option for creating the model of a single component. By the way, in Mac 113 and well, the main part of CVE 101, well, the object is a single component, not an assembly. Well, assembly modeling of assembly modeling, how the model of an assembly can be created. These are the questions to answer or subjects to deal in the second engineering drawing course. It is called in mechanical engineering curriculum in Northern Cyprus campus is Mac 114. It is a math course for mechanical engineering students. For the others, optional elective course. Okay. Of course, all of the interested students welcome to the second course. Since the second course is not obligatory, but it is quite valuable to its content for all the engineering students. Well, except mechanical engineering students, for the others it is optional. Regarding that, it is optional, but it is a very valuable course. It is one of the chapters, especially for the interest of all of you. It is about assemblies. You know, in CVE 101, that course, well, from the content of Mac 114, selecting the introductory records about assemblies, and then how the model of a structure can be created. To answer this question as well, I already provided the hyperlinks in Meta class for civil engineering students. Interested civil engineering students can find those video records. Well, at the beginning I said in CVE 101, these are optional lecture notes, optional video records, only for the interested students. Well, I provided the necessary links to allow the students to access the resources. Okay. Yes, in Inventor, after selecting this option, then this means we selected millimeter, you know this. Okay, and create the model of the component while inputting the constraints as dimensional constraint or coordinates of characteristic points. Sure, Inventor will record the written numbers in millimeter. You know this quite well. But say that it is a civil engineering product, the model of the walls of a house, for instance. I recommend in Inventor, do not change the default configuration. Create the model of the object using millimeter. But in civil engineering drawings, architectural drawings, it is more common, more convenient to show the dimensions not in millimeter but in centimeter. Well, in my record, this lecture and the following ones, while opening the parentheses for the interest of civil engineering students and then demonstrate. Well, although you created the model using millimeter, how you can show the dimensions in centimeter? Answer this question. In Inventor, in AutoCAD as well. In Inventor, selecting English option from this list in this pane, then this means you selected inch. Okay? Creating the model of the component, select this template, and while creating the model of the component, whatever you type as the size or the coordinate of something, it is going to be interpreted by the software in inch. In the parentheses, it is also noticed inch. Okay, and then at the view creation stage, select this one, and then create the views. Inventor, thanks to this selection, can understand that you select the third quadrant and accordingly create the views. Software will create the views in the third quadrant. You know, such things. Of course, at this stage, I'm going to answer the question. Although, you created the model inputting the values in inch, how you can show the dimensions in feet? Foot is the unit of measurement widely used in civil engineering in architectural drawings. Not inch, but foot. I'm going to answer the question as well. Although the object sized inputting the values in inch, how the dimensions are shown or can be shown in foot. Okay. Not this video record, but the next video record, it is going to be the software Inventor. How about AutoCAD? In AutoCAD, yes, I said that the views are drafted. I drafted them, not created. Didn't use solid model for having this set. Well, obvious, because at the background you see, opening the, asking the visibility of transfer line layer, how, drop the list of the names of the layers, and then turning the length of transfer line layer on. And then, make the content of that layer visible. And, you know, in the content of transfer lines, I have the necessary transfer lines. These are, quite well. Talking about the ABC of orthographic projection, I have already talked about the value of transfer lines. Drawing the transfer lines at the beginning, we mark the projections, the views of characteristic points, and then join the characteristic points with proper joining lines. For instance, after having the projection of this point, projection of that point, then between them we have this intersection. Start line drawing process if you're drawing the projections line by line, and then indicate this point, indicate that point in AutoCAD. Yes, after having the images of the points, then start the line drawing process and then join the images of the characteristic points with the necessary joining lines. The joining lines mainly will be what? Intersections or the edge view of a surface. For instance, there is a surface here. While we're observing the object in this direction, we see a line, but that line, on the view corresponds to the edge of this surface entirely. Also, the image of this intersection, coincide with the edge view of the surface, and this intersection coincides with the edge of the surface. That intersection coincides with the edge view of the surface, and so on. Yes, we have, you see, a surface to its boundaries, but individually, if you consider the boundary lines, then say that this intersection, this intersection, this intersection, this intersection, and so on. At the view reading stage, these are important, of course. Well, the views are okay, correctly drafted, I am sure. Well, take the visibility of transfer lines from the screen, and then say, using scale 1 to 1, under scale 1 to 1, I drafted these views. Okay, that is the title block. Okay, drawing scale is 1 to 1. These are the views: front view, top view, left side view, because you know quadrant symbol is the first quadrant symbol, and I'm sure these are the primary principal views: front view, top view, left side view. I have the necessary symmetry axis, etc. The views are correctly drafted ones and ready to show the dimensions. Okay. I drafted the images, okay, at the transfer lining stage using millimeters. Okay, so I completed the imaging stage, view drawing stage, using millimeter. So normally in mechanical engineering drawing, yes, show the dimensions in the same unit, millimeter. But if it were the view of a house or a building, then, well, the dimension, although I drafted the projections using millimeter, yes, it is recommended, you know, civil engineering students know my notice or recommendation via watching the previous video record in CVE 101. I said that using the default configuration of AutoCAD, okay, have the views in millimeter. But at the view, at the dimensioning stage, for showing the dimensions, well, I'm going to educate you, opening a parenthesis, civil engineering students. Well, what is the thing to do? For showing the dimensions, not millimeter, but in centimeter. Well, at the beginning, I know, since this video record is not only for mechanical, chemical, petroleum, and aerospace engineering students, but it is also for the interest of civil engineering students. To be able to keep the, say, the interest of civil engineering students, okay, well, at the beginning, I want to open a parenthesis and then answer the question. Although the drawing has been drafted using millimeter, how the dimension can be shown in centimeter? At the beginning, I want to answer this question, but say, of course, there are some other things to know, okay, about dimensioning stage. I'm going to demonstrate or talk about the others in detail later. Or just, well, say I gave up. First, well, pass through the dimensioning configuration stage, okay, and then open that parenthesis and then demonstrate. Although the view has been drafted in millimeter, using millimeter, at the dimensions stage, how the dimension of the feature is shown in centimeter. Answer this question, say, at the intermediate stage. Okay, now, let's start formally and then go ahead. Well, one more thing. Well, call your memory. Well, this view is ready to start to the dimension stage. But say to call the memory, well, start from the beginning and remind you on the things to do. Well, you open AutoCAD. Okay, the drawing's not ready yet, not drafted yet. Okay, you know the thing to do. First, click on New File Creation button. And then in AutoCAD, in this dialog box, obey to the recommendation, make the template selection from light background folder. And then, you know, we have a list. The listed ones are template options. Well, if the quadrant which you selected to imagine the object as located is the first quadrant, make the template selection on this option. It is the template option. It has been configured by the programmers of AutoCAD in accordance with the rules of the International Standardization Organization. ISO is the acronym of that organization. If you select this template, then AutoCAD will automatically take the unit of measurement as millimeter, not centimeter, millimeter. At this point, you know, civil engineering students, you know quite well. After opening AutoCAD file, it is possible to change the unit of measurement from millimeter to centimeter, for instance. Although it is possible to make such a changing, but I do not recommend. Don't make such a changing. At the dimensioning stage, make the necessary changing, not at the drawing stage. Dimensioning stage, well, I'm going to educate you how the unit of measurement, unit of the dimensions, not in millimeter, but while the dimensions can be shown in centimeter. At the dimensioning stage, not at the drawing stage, because if you change the unit of measurement, remind you how, select ISO template. If you're going to have the projections as third quadrant projections and going to use inch, make the template selection selecting this option. ANSI is the acronym of the American Standardization Institute, American National Institute for Standardization. If you select this template, then AutoCAD can know that you're going to draw third angle projections, third quadrant projections, and unit of measurement inch. Whatever you type as the size of something or coordinate of a point, it is going to be recorded in the memory. Okay, it is done by the software in inch. Well, using my technique, although you drafted the projection in inch, you can show the dimensions in foot. Okay, I'm going to answer the question for the interest of civil engineering students at an intermediate stage. Well, select the template option. Here I selected ISO and then say open. Then yes, I am sure I have an unlimited paper in the domain, in AutoCAD environment. If you're going to say not model, but you're going to draw the projections, I mean you're going to use the old-fashioned part, classical part of AutoCAD, two-dimensional tools of AutoCAD, well, it is strongly recommended. Have a paper simulation. How? In AutoCAD Mechanical, okay, select Annotate tab. Along the annotation ribbon, find Sheet panel, and in Sheet panel you see Title border. Select this option with a click, and then in this dialog box, from this list, you know quite well, select the size of paper, title block format A or B, and drawing scale. Okay, select the drawing scale. If the object is a little one, while the size of the object is comparable with the working space of A3 size paper, you can select 1:1 as the drawing scale. But if the object, for instance, say that it is a house and the paper is A3 size, you see here from here the standard size for A3 size paper, 420 millimeters by 297 millimeters. but the object is a civil engineering architectural object. It is a house. The width of the house 10 meters, 10,000 millimeters. So if it is so, then select diminishing factor for fitting the views of such a big object. For instance, select 1 to 40 as the diminishing factor. Okay, if you select the scale factor here, this stage, and then say OK, and then, well, at this stage, you know quite well, already studied on such things after talking about the standard papers, answered the question how can have a paper simulation in AutoCAD and edit it, how can have paper simulation in Inventor and edit it. Already studied on such things quite well and deeply. Well, here the lower left hand side corner is located at the origin. So write the abscissa value for the lower left hand side corner as 0. Click on comma key. Write the ordinate value for the lower left hand side corner of the paper simulation as 0, and then press enter. And then you know my method, skip the text typing stage, saying simply OK. Do not write anything in this dialog at this stage. Thereafter, to fill in the title block, use the text facility of the software. You know this quite well. Here, if you're going to draw the projections, not create but draw, I mean, well, the issue not the model creation issue but view drawing issue. Yes, having such a paper simulation, believe me, is for your convenience. Well, the scale factor, for instance, 1 to 40, then, well, whatever you write as the size of the entity feature of the object, then that size value will be multiplied by the scale factor, and it is going to be created 40 times smaller. At the dimension indication stage, well, if you have such a template, AutoCAD knows that diminish the projection 40 times, then whenever you show the dimension on the projection, then AutoCAD at the background automatically multiplies the measured value, will multiply the measured distance at this stage by the inverse of scale factor, and the actual size of the feature going to be shown. Don't forget, showing the dimensions, we do not show the size of projection. We show the size of the feature, size of the object. Well, scaling, thanks to having such a template, and of course keeping the configuration of the software as correctly configured at the background, scaling will be automatically achieved by the software. Drawing the projection, it is going to be under the scale created, while showing the dimensions as well. Say show the dimension, the measured distance at the background will be multiplied by the inverse of scale factor, and AutoCAD will show the size of not the projection but the object, the feature of the object. It is automatic. So while having such a template is strongly recommended. And then the rest, you know, layer creation issue. At present, if you bring a new paper simulation in at the beginning of file creation issue, you have 1, 2, 3 system layers as automatically activated. And then, you know, already studied on the structure of AutoCAD, transparent papers layers. Well, create the necessary layers one by one, or activate the system layers. Well, for instance, for transfer line facility, this is the transfer line creation facility of software. Well, parallel with full distance option is widely used for creating the transfer lines at distance away with respect to a certain datum or with respect to each other, to be able to have the projections of the characteristic points having the same x, y, z coordinate respectively, of course, not only on one of the principal view but also on the others. You know, the drawing technique. And whenever you use transfer line facility for the first time, then the corresponding system layer is activated. Okay, there is a system layer. well, the transfer lines are created in that layer. I don't want to talk about layers in detail, but here just try to remind you. Well, in this file, yes, the layers which are used in drawing these projections, well, one of them visible layer, in which I have the projections of the visible entities. Turn the lamp of this layer and then see that it is true. Yes, you see, I took the visibility of the projections of the visible parts as their visibilities again. And then there are hidden features. While observing the object in this direction, well, the holes are hidden. Yes, I drafted the images of the holes, contour bore hole and simple holes here and there using the other layer, hidden layer. Yes, turn the lamp of hidden layer and then see that it is true. An axis of symmetries, yes, using this tool I created the symmetry axis. Well, you know, for these tools, the system layer, there is a system layer in which AutoCAD creates and keeps the axis of the symmetric entities, axis, symmetry axis. And dimensioning parts. Here, well, either by using the dimensioning tool, well, this is the dimensioning panel, and these are the tools of AutoCAD. In few minutes, start using this facility. Whenever you use dimensioning facility for the first time, or equivalently if you want, after dropping this list and making a click on dimension option, then the system layer will be activated. I activated that system layer and then bringing the layer manager, managing dialog box, you know, clicking on this button, and then I rename it. Well, replace the code of the layer with this word, dimension. It is just for reminding me or noticing a reader that it is a layer in which dimensions have been shown or going to be shown. Okay, remind you, configuration stage. Well, activating system layers, or if the layer is a user created layer, then after creating the layers, bringing the managing dialog box and then rename them, and then select the line color for the layer, line type for the layer, and line thickness. Well, I have already configured dimensioning layer passing through such a stage, and I selected for dimension lines, well, see which color, eggplant color, this tone. Remind you, there is no standard color for dimension extension lines. It's up to you. You can select any color, but don't forget, if you're going to take the printout at the end over a white paper, yes, white papers are widely used, okay, then do not select a soft tone. Never select white as the line color for extension, dimension, or any line, because paper is white. You selected white color, so when you take the printout, you see nothing. So select the dark tones relative to white. Avoid selecting yellowish, for instance. Selecting light green, light blue, cyan. Select dark tones. Well, the one selected by me is eggplant color, this color. It is, contrast is good enough. Line type, you know, extension dimension lines just are continuous lines, and thin lines, 0.2 is the thickness. Yes, what I mean here, bringing this managing dialog box, be aware at the stage, layer activation, layer creation stage, I have already configured the dimensioning layer. So, well, I am sure when I show the dimension of something, the extension lines and dimension lines will be in eggplant color, continuous lines, and 0.2 is the thickness. Okay, and then say OK. And then now, at the beginning of the dimensioning stage, configure the dimensioning facility. If you say, Hocam, why it is necessary? Well, why the coders, programmers of AutoCAD do not configure the software already and then make life for us easier? The answer, obvious, because AutoCAD is used not only by mechanical engineers, not only by civil engineers, but also architects, but also chemical engineers, but also aerospace engineers, and so on and so forth. Well, different branches of engineering, we have different conventions, different format requirements. So AutoCAD cannot know. It is not a new generation software, you know. Well, just considering the drafted thing, AutoCAD cannot understand that, it is a house, so well, automatically select the civil engineering format. It is an aircraft component, so select the convention of aerospace engineers. No, AutoCAD is not such a software. Well, user, drafter should teach to the software, okay, whether it is in this format or in the other format. I mean, configuration stage. How? If not yet, well, drop this list. You know, if you simply open AutoCAD, you find at the top quick access menu bar, and under the quick access menu bar, tab menu bar. Well, to be able to bring the configuration dialog box, well, need to bring, invoke drop down menu bar. You know how? Bring the cursor onto that, say, by the way, am I recording? Yes, recording all the things. Okay, good. Bring the cursor onto this listing arrow, drop the list, and from the list select show menu bar option. It is to invoke drop down menu bar. After dropping the drop down menu bar, click on format option, and then you know this famous list to find the option to change text style. Already talked about it. It was in the content of one of the weeks. Point style, but here now the style to configure is dimensioning. Select dimension style option with a click, and then after having this dialog box, well, select AM ISO or ISO 25. AM ISO is more general, but here for this set of projections I selected ISO standards, yes, because I know that it is first quadrant projection. And then instead of selecting new dimensioning style, it will take greater time and effort. Select modify, because automatically selecting AMISO option, then AutoCAD using the common agreements in all the engineering and architectural branches, well, automatically selects some options. Well, some of the options are in general the same in any engineering branches, but some of the others are special, okay, for civil engineers in civil engineering applications. Well, this is the option to select. Well, architectural applications, this is the option to select. The specific options are not selected. To be able to use the automatically selected ones as the same, because these are in general under agreement in any standards, well, or in any engineering branch, select not new style but modify option with a click. After clicking on modify option, then you find the configuration dialog box finally. Okay, start from the left and go to the right. At the top of the managing dialog box, modification dialog box, we have the tabs: lines, symbols, text, fit, etc. Lines. Okay. Well, this pane you see from the title obvious about dimension lines. Configuration of dimension lines. This pane about the extension lines. Okay. Well, here color. Drop the list and then do not select any color. Just select by layer. Why? Because at the beginning remember, I called your memory saying that, yeah, well, I already activated dimensioning layer, and at this stage in layer managing dialog box, in that dialog, I selected the line color. You know, I selected eggplant color. So, well, that stage, I recommend do not make any changing. If you correctly configure the dimensioning layer, just to say that line color is the same as you configured. From the list, select by layer. This means whatever the selected color in the configuration of the dimensioning layer is, then yes, show the dimensions as the same in the same configuration. Whatever the line type, we selected, you know, configuring the dimensioning layer, continuous line. So do not try to think about which line type. Yes, just select by layer. Line weight means line thickness. Already configured dimensioning layer, you know, selecting 0.2 as the line thickness. It is the standard recommended thickness value for thin lines. Extension lines, dimension lines are thin lines, you know. So select from this list similarly, not any thickness value, but by layer option. Well, since the dimensioning layer has already been configured, selecting 0.2 millimeters, sure that line thickness will be the same. Here within this box, write 10 millimeters. What is that? Baseline spacing. Remember, the distance between the most out boundary of the projection and the first dimensioning row, recommended value is 10 millimeters. Selecting baseline spacing 10, well, can have the dimension lines 10 millimeters away. Okay. Extension lines. The same. Reason is the same, so option to select is the same. By layer, by layer, by layer, by layer. And then this pane, this part of the dialog box. Remind you, extension lines are started from the limiting points of the feature. The dimension is for that feature, for showing the size of the feature. How? At the beginning of extension lines, leaving an empty space in the order of few millimeters. Depending on the size of the projection, 1 millimeter, 2 millimeters, 3 millimeters, or a little bit more. In this example, the space to have at the beginning of extension line by me is 2 millimeters. These are in millimeter. And you know the other agreement, other format requirement. Well, extend the dimension extension line after the tip of the termination symbol of dimension line. Mechanical engineering drawings, it is an arrowhead. Civil engineering drawing, it is an inclined tick, or architectural drawing, inclined tick, you know. Beyond the termination symbol, furtherly extend the extension line. How many millimeters? Well, 2-3 millimeters. 2 is a reasonable order for this size of projection. Okay. And then yes, well, about lines, extension dimension lines, and the other format requirements, the things are those, well, in this dialog. Clicked on symbols and arrows option, and then, yes, if it is an architectural drawing or civil engineering drawing, then termination symbols for the dimension lines, drop this list and select architectural tick or oblique option. If you select oblique option, termination symbol will be an inclined tick, thin, architectural tick, thick, inclined little line. Select this one. But since here, as I said, as also obvious that it is not a house, it is not a building, but the object in this example which I selected is a machine part, machine element. So I should select the, in the convention of mechanical engineering, close field option. Yes, termination symbol in mechanical, aircraft, petroleum chemical engineering applications is a solid arrowhead, blacken arrowhead. So select first termination symbol, second termination symbol, and then writing the technical notes in civil engineering applications, architectural applications. It is quite common on the assembly's detailed drawings. Well, instead of using symbols and identification balloons and on the assembly drawing parts list, civil engineers and architects use leader line technique. With a leader line, indicate the layer of the wall and then write a technical note. Well, leader lines, not a matter it is engineering drawing, architectural drawing, or the standard is ISO or standard is American, quadrant first, quadrant third. Well, it is under common agreement in any branches, in any unit system, in any format of any standard. Well, the leader lines use arrowheads. Okay, so select from this list close field option, blacken arrow size. Termination symbol arrow size is an isosceles. Yes. What is the length of the arrow? For A3 size drawing, 3 millimeters is the recommended one. So into this box write 3. And then at the center points, shall you use additional marker? If yes, select mark radio button. No need, because we mark the center points using axis of symmetries. Okay, for a circle, for instance, show the horizontal vertical axis. The intersection point is the center. No need to mark the center point one more time. So select none option. Okay. And then these parts, well, not related with CVE 101 or MEC 113. Arc length symbol is used, well, showing geometrical, some kind of geometrical tolerances. Geometrical tolerances is the title of a chapter in the second course. MEC 114 is the code of that course. So, well, this part is not for the interest of the students. They are taking MEC 113 or CVE 101. Keep the automatically selected ones as the same. Okay. And then, if you already configured the text facility of the software, skip this option. But if not, well, by this time didn't configure the text facility, then select text option. Well, in this dialog, it is possible to bring the text configuration dialog box. How? By clicking on this button on which we have triple dots. Yes, I think you remember this dialog box. It is the text configuration dialog. How this dialog box can be invoked? Normally, if it is not dimensioning issue but text typing issue, click on format option along the drop down menu bar and select text style option. After making the selection, this dialog box appears. You know which font name is recommended, okay, to have the text in standard appearance. It is Arial. So from this list, select Arial. Italic style is not a must, it is recommended. Select italic or regular, and then into this box. If it is for dimensioning purpose, well, write the value into this box for having the font height of the dimensions as automatically selected in the correct order. Otherwise, for each dimension, need to select the height value during the dimensioning stage. Well, on the page, I'm going to show the dimensions obeying to the recommended, using the recommended font height. You know, for A3 size paper, well, show the dimensions, selecting the font height for the numerals, 5 millimeters. It is the recommended value for text, letters of text, and also for the height of the numerals, dimensioning numbers. But you know the trick in AutoCAD. AutoCAD is an old-fashioned software, and whatever the drawing scale is for the template which has been selected is, then the same scale factor is applied well for the showing the dimensioning numbers and also writing the text. So well, into this box, instead of writing the font height, write the result of that calculation. Remember, repeatedly set the same notice. Well, the recommended font height times the inverse of scale factor. Calculated, and then write the result of that calculation into this box. In this example, since the scale factor for this drawing is 1 to 1, so inverse of 1 to 1 is 1. 1 times 5 is equal to 5. Do not say that it is the font height. It is the font height times the inverse of scale factor. And then yes, clicked on Set Current button. It is to say that apply this changing for the existing drawing, and then close this dialog box. And then turn back to this dialog. Well, text appearance, text style. Yes, we configured the text style. Text color. Well, in the structure of my template, I already activated text layer, okay, and configured. Bringing the layer managing dialog box, I have already configured the text layer. So well, because of that reason, from the list, as the text color, I'm going to select by layer option. It is to say that whatever the line color for the text layer is, then for the numerals will be the dimensions, the line color will be the same by layer. Fill color, select none option. Well, if you select the color from this list, then well, there will be a background color for the dimensions. Having a background color for the dimension is really a poor practice, because color may prevent the reader from seeing the number. Do not select color here, select none option. Text height. If in the text configuration dialog, at the text configuration dialog already configure the facility, then yes, I selected font height times the inverse of scale factor. So the written number in the text configuration dialog is automatically written within this box. Cannot change this number here. To change this number, well, you must click on this button, you know. And then text placement. Well, ISO says that show the dimensions above the line. So from this list, select above. And other format requirement, it says that show the dimension as centered along the dimension line. So select from this list centered option, justification option. And then showing the dimensions, we write the numbers from left to right. So select left to right option. And then, well, another recommendation, talking about the dimensioning format, well, I remember, unfortunately, I forgot to talk about the meaning of this number. Well, during the CAD application stage, showing the dimension, I'm going to answer the question, what is the meaning of this number? Well, it is recommended in ISO format, showing the dimensions between the dimensioning number and the dimension line have a space in the order of 1 millimeter. Write the space value into this box. Why? Whenever the dimension of the feature is wrong at the drawing stage, well, drafter made a mistake and the distance from here to there is in the wrong value. Well, instead of trying to change the drawing, just change the dimension. But whenever, although the projection is wrong in size, but you change the dimension manually, then that replaced dimension, the new value must be underlined. Underlined dimension means on the projection the size is wrong, but the dimension which has been shown is the correct dimension. To draw the attention of the reader that there is such a fault on the projection, yes, it is a must. Such a case, underline the dimension. Okay. Yes, the for underlining purpose, the space needed between the dimension number and the dimension line is in the order of 1 millimeter. It is a reasonable value. Why 1 millimeter? Because underline is a line, its thickness is 0.5. So, well, 1 millimeter allowance is sufficiently large for having an underline. Its thickness going to be 0.5 millimeters. Okay. Text alignment. In accordance with ISO, we show the dimensions as it is demonstrated in this example drawing as parallel to dimensioning line, in alignment with the dimension line. So select alignment radio button. But in third angle projection, ANSI says that, well, write the dimensions always as horizontally oriented. So if it were third angle projection, then I would say that, yeah, select horizontal option. It is to have the dimensions not in alignment but always as horizontal oriented. But this is first quadrant projection. ISO is the standardization organization to obey, and it says that show the dimensions in alignment with dimension line. So this radio button is correct. Yes, in this dialog, these are the things to do. Continue. Fit. Here there is a method. In the method scale, for instance, in civil engineering, I said at the beginning, one more time, draw the projection using millimeter, but at the dimensioning stage, show the dimensions in centimeter. Well, one method, in one of the method, actually it is not my method because some cases it may not work, but it is a method. Well, in this dialog box, select this option, scale for dimension feature. Use overall scale option, and then if the drawing is the one drafted using millimeter, but the dimension you're going to show the dimensions in centimeter, you know, 1 millimeter is 0.1 centimeter. So as the scale factor here, write 0.1. Yes. Then the measured distance at the stage, at the background, is multiplied by 0.1. Okay. Dimension, instead of it is shown in millimeter, it is indicated in centimeter. One method is this one. Okay. But I am not going to use this option because it is not my method. But say that, be aware, it is for the interest of civil engineering students. So the other things, do not change any other automatically selected ones. Well, primary units. This layer is extremely important. Not this layer, sorry. This dialog is configuration dialog, modification dialog is extremely important. Because at this stage, in this dialog can fix the number of figures, okay, at the decimal part of nominal dimensions, nominal size of the features. Well, at this point, remind you, bringing this slide from my lecture note. Well, this is the question. Showing the dimension, for instance 30, shall you write a 30 or 30 dot? 30 is the integer part. And then dot, in engineering we use dot as the separation symbol between integer and decimal portions. And then show the decimal figures, the figures at decimal place. That is the question. Well, the answer comes from the rule of ISO. ISO says that if the deviation starts from tenths, in this example you see 0.1 is deviation, and it starts just after the decimal marker from the tenths. If the deviation for the dimension of the feature starts from tenths, then show the nominal value of the feature as integer. That is the ISO rule of ISO. So, obeying to this rule, then see, deviation for 30, you see, starts from hundreds. Other deviation starts from hundreds. Since both of the deviations, or at least one of them, just starts not from tenth but hundreds, this dimension can say that is wrongly indicated. The correct dimension, the correctly shown dimension, not this one, this is wrong in accordance with ISO, but this is the correct one. 30 dot, since this 0, these are space holders, cannot say anything at the decimal for the decimal part of the nominal value, then we put a dot and here use a figure, one figure. Precision is 1. Well, the figure, who knows, is what? Well, one design, it may be 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9. But it is a must. There must be one more figure. Okay? That is the rule of ISO. And then, well, for our example, well, I'm going to use the model and then quickly check what is the order of magnitude for the features. Inspection tool of inventor, measurement, and then indicate this age. You see it is 30 millimeters. Reset the instrument time, making an arbitrary click in the atmosphere, and then indicate this feature. It is near to 50. Reset. Radius of this one, it is 25. Okay, radius of the channel, it is 20. Okay, radius of this end, 30. Okay, thickness, well, one more time I forgot, 30. Okay, and the width of the object from here to there, I see 175. So the order of magnitude of the features, I have an idea about the orders. Okay, and then, well, in my lecture note, it is about size tolerances. Then see, for non-functional dimensions, in this example, in my example, to demonstrate if a feature is functional, then its dimension is shown. Of course, you know, today's format with the specifically selected tolerance grade. Well, demonstrate how a functional dimension is shown. In my demo, consider that this channel is a functional feature. Okay? For this channel, showing its size, I'm going to show the dimension as functional. But for the other ones, I'm going to say that except this one, the others going to be in contact with atmospheric air. So all the others are non-functional dimensions. For non-functional dimensions, you know, we refer to such tables. You know, general tolerance, part 1. For linear distances, refer to the first table. For angles, third table. For chamfer, size of chamfers and external ready, the second table. Well, say that in our case, for non-functional dimensions, tolerance class is medium, or fine, or coarse, or very coarse. Well, the order of magnitudes, some dimensions are in this range, 30, 25, 20, etc. Well, in this range, see the deviations. This is quite important. How many figures you need to show in showing the dimensions? That is the question, and trying to answer. For this range, you see, not a matter the tolerance class selected by the designer is fine, medium, coarse. You see deviation starts from tenths. Deviation starts from tenths. Deviation starts from tenths. Some other dimensions are in this range. Well, you see deviation starts from tenths, starts from tenths, starts from tenths. And the width of the object 175, it is in this range. Okay, deviation starts from tenths, deviation starts from tenths, deviation starts from actually it has an integer value. But here for the measure of the dimensions, especially non-functional ones, making such a control now can ensure that I am sure now that in accordance with the rule of ISO, it says since the deviation starts from tenths, then the nominal values are to be shown as integer. Okay, then after this reminding and underlining, turn back to here, and then drop this list and then select. Shall you show the nominal value as integer? If yes, select this one. Shall you show the nominal value with one significant figure at its decimal part? Select this one. Shall you show the nominal value as a decimal number with two figures at its decimal place? Select this one, and so on. In our case, since the deviations for non-functional dimensions are almost all, it is true, start from tenths, then nominal values are to be shown as integer. To enable the software to show the nominal values as integer from this list, precision list, select 0 option, this option, and have the dimensions as integer. It is, I think, clear, and this stage is extremely important. If you by mistake, for instance, select this option saying that it is quite good to show the dimensions with lots of figures at the decimal part, and then in Cyprus cannot find a manufacturer, okay, in Turkey cannot find a manufacturer, what you say? The tens, hundreds, 10,000, 100,000, millions, 10 million, 100 million of 1 millimeter is the precision, the minimum distance. Even in the world, in United States or Japan, cannot find such a manufacturer. Never make such a mistake. Show the nominal values while checking the deviation values, sure that as integer. So any company can manufacture your product. Even in Cyprus you can't find. Okay. And then decimal separator, if the dimension is the one, need to show it as not integer but decimal value, then separation symbol in engineering is dot, period or dot, not comma. Okay, select period. And then this is important. And it is the other technique. Measurement scale. Bringing the cursor into this box can find such a notice box. AutoCAD saying that keep this number as 1, as unity. If you have a template and it has a certain drawing scale, then using that template at the drawing stage, write the size of the features using actual orders, not as scaled. For instance, the thickness is 30, write 30. But if the scale factor, for instance, 1 to 2, then written number 30 at the background is automatically multiplied by 1 to 2, it makes 0.5, and the line is created not 30 millimeters in length but 15 millimeters. It is achieved. Scaling is achieved by the software automatically. The projection is under a certain scale, so it has been diminished or magnified, whatever it is the case. Well, thanks to keeping this number as unity, well, can enable software at the dimension indication stage to multiply the measured distance by the inverse of the scale factor. Okay? So, you drafted the projection using millimeter, and you're going to show the dimensions in millimeter. Then yes, keep this number as unity 1. But in civil engineering, yes, you drafted obeying to my recommendation. Using millimeter, you drafted the projections. Why I recommend, although it is possible to change the unit of measurement for the entire of the template in the domain from millimeter to centimeter, but it is not recommended by me. Why? Before answering this question, well, for a while, cancel this configuration stage, close this dialog box, okay, and then remind you how the unit system can be changed. For instance, yes, one of the way to follow is this one, format, okay, and select units, and then jump to here and make a click. In the dialog box, well, you know, since I selected ISO template, AutoCAD knows that millimeter. But if you're going to draw the things using centimeter, the written numbers or the numbers which you input is to be recorded in centimeter, drop this list and select centimeter option. Although it is possible to make such a changing, I do not recommend, because if you change the unit of measurement at this stage in this dialog box, okay, well, the new dimension, millimeter, okay, well, unit will be not only for the drafted things but also the paper simulation. And you know the size of A3 size paper, 420 millimeters. But if you change, well, obeying to the recommendation of some others, okay, selecting from here unit option, change unit from millimeter to centimeter, or from this list, you know, drawing utilities, it is the other way, find the same option, units option, and then change the unit from millimeter to centimeter, then the unit of the paper simulation will be centimeter. Well, the standard paper size 420 millimeters for A3 size paper, it is the width value, but after making such a unit changing, it is going to be 420 centimeter. Unfortunately, in this old-fashioned software, it is a fact. So since it is so, and having the paper 10 times bigger than the standard size is really a poor practice and quite misleading, well, changing the unit system, selecting unit option and bringing the unit changing dialog box is certainly not my method. My method is different. Do not make the unit changing. At the dimensioning stage, change the unit of dimensions. How? One method. Well, now continue, dimension style, and then modify, and then, you know, already talk about lines, symbols, arrows, and then text issue. Okay, these are all already studied. And then, well, one method in civil engineering drawings, to show the dimensions. Although you drafted the projections obeying to my recommendation in my method in millimeter, but at the dimension stage, show the dimensions in centimeter. Then, well, select use overall scale radio button, and then not one, but say to show the dimensions in centimeter, 0.1. It is one of the method. The other method, well, primary units dialog box, select the precision, etc. And here, scale factor. This is the other method. Well, scale factor, if you drafted the projections in millimeter and you're going to show the dimension in millimeter, yes, you must keep this number as unity, as it is written in this notice dialog box. But in the second method, other method, if you're going to show the dimensions in centimeter, well, although you drafted the projections in millimeter, well, replace unity, this number, with 0.1. Then at the dimensions stage, the indicated distance will be multiplied by 0.1, and then the number will be shown 10 times smaller. So, well, the number, if you put a legend at the title block, say that dimensions are in centimeter, then the dimensions shown on the technical drawing will be considered by the readers in centimeter. Although this is a method, but some cases in this old-fashioned software, that method as well may not work. Although it is a method, but it cannot guarantee that while writing 01 into this box, you will have the dimensions in 10 times smaller, so can be interpreted as centimeter. My method is different, but be aware these are also the methods. But here I'm going to keep it 1, not changed. For civil engineering drawings as well, I keep this number as equal to 1. And then, well, angular dimensions, decimal degree, both of the standards say the same thing, show the angles in degree. So select from this list decimal degree option. Precision, for the angles, well, similarly check how many angles you have to show. And if for the measure of the angles, the deviation starts from the first figure, where is the table to check? Here is the table, the third table. Okay, non-functional dimensions, angles. Fine, medium, coarse, very coarse. Okay, if the length of the raise of the angle is in this range, less than 650, maximum 50, greater than 10 millimeters, then you see deviation 1 degree, 2 degrees. Here starts from tenths. So, well, show the angles in our example with 0 precision, without any figure at the decimal part, so show it as integer. Do not say 30 point something, because deviation starts from tenths. Okay, so 0 precision from this list, select 0 precision. And then, well, alternate unit. Well, some cases it is recommended. For instance, your technicians partially familiar with millimeter, but the other technicians, for instance, in your company, the other technician is just from United Kingdom or United States, and customarily that person familiar with inch. Okay, to be able to show the dimensions by unit, millimeter, and also in inch, then, well, select this box, and then thereafter can have the dimensions in millimeter and also in inch. Okay, but here, well, say that there is no such a technician in the company in this scenario, so no need to show the same dimension with 2 different units, millimeter and inch. Well, show the dimensions only in millimeters, so, well, skip this configuration part. Tolerances, well, my method, there is nothing to change in this dialog box. At the dimensioning stage, showing the dimensions for functional dimensions in my method, you're going to see how the functional dimension can be shown. So, well, here do not make any changing, and then finally can say that finish the configuration stage, and then clicked on set current button. It is to say that well, consider this new configuration for the existing drawing. So select set current option and then close this dialog box. Well, since I explained lots of things, well, the configuration stage took lots of minutes. But after learning the necessary things, then, well, start from the beginning. I am sure maximum in few minutes, 2 minutes or 3 minutes, can pass through the configuration stage. And then the rest, this means you are ready to show the dimensions. Okay. Here it is the time to open the box. Okay. And then, well, for the interest of civil engineering students, okay, I'm going to make a quick demo. Well, just to say that, yeah, well, although during the configuration stage, I sufficiently talk about it, but say, make a quick demo. And one of the video records, it is going to be just for civil engineering students. Well, on the plan view of a building, I am going to do similar things. Although it is so, well, here, for keeping the interest of civil engineering students, okay, still to the end of this classwork, okay, on this example, open a parenthesis and then say that in civil engineering. Well, for instance, you had the paper simulation selecting the scale factor 1 to 40. And then say that plan view in this layer, well, as I said in lecture, classwork, class demo, using asynchron technique this week, you know, well, I'm using asynchron education technique because, well, the online class time is national holiday. So, well, said that record the video films using asynchron technique. Okay, it is one of the video records. The other video record, well, I'm going to formally, from the beginning to the end, pass through and educate the civil engineering students on very valuable details, complementary things. But here, very quickly, I want to demonstrate how the dimensions are shown in centimeter. Since I had this paper simulation at the beginning selecting ISO template, now AutoCAD knows that whatever I type, it is going to be in millimeter. Okay, in this layer, well, I'm going to skip layer configuration stage, etc. Well, say that the main part of plan view, create a rectangle and say that it is a plan view. Omit the other things, okay? Well, the width of the little house is 10,000. Yes, into this box, what I am writing, 10,000. Sure, it is going to be recorded in millimeter. Tab key, and into the other box, write the depth of the house. It is, in this example, 6,000. In meter, 10 meters by 6 meters. But it is in millimeter, 1,000. Press enter. And then say that finish the plan view and the time to show the dimensions. Okay. Well, actually, I'm going to demonstrate how the dimensions are shown in detail, turning back to this example. But, well, here in the parentheses, quickly, well, complete my demo. Select this option and then dimensioning facility, and then show the dimensions. From here to there, click, and then show the dimension. Yes, it is going to be indicated, you see, 10,000 in millimeter. You see here, I didn't change in my method. Well, format, dimension style, and I said that modify in this dialog box one method, select primary units, and here scale factor not 1 but 0.1 to have the dimensions in centimeter. Although, well, most of the cases it works, but some other cases may not. And the other method, select say alternate unit option, sorry, not say fit option, and then here it is the other method, write overall scale factor not 1 but 0.1. Since these are not my methods, Well, keep this number as unity, and also scale factor is unity. Since this is in unity, then normally when you show the dimensions, yes, if the projection has been drafted in millimeter, the dimension will be shown in millimeter. You see, I created this rectangle 10,000 millimeters, and when I asked the dimension, show the dimension, I said it is 10,000. Okay, well, have the dimensions first in millimeter. Well, show the height of this rectangle, but if it is plan view, the depth of the house, okay, yes, it is 6,000 millimeter. Well, show the dimensions in millimeter. In my method, and then how you can change the unit from millimeter to centimeter. See my method. Indicate the already shown dimensions. Select all of them, clicking, and then you see in this ribbon, along the ribbon, it is written dimension text. Drop this list, and then yes, yeah, well, it is my method. Linear scale factor. Instead of writing 1, write 0.1 if you're going to show the dimensions in not millimeter, although you drafted them in millimeter, but centimeter. Press enter. Okay, and then close this dialog box. Okay, that is it. And then see the dimensions. Not 10,000 but 1,000. Not 6,000 but 600. And of course, well, at the title block, a notice is a good practice to write. Say that units are centimeter. Units are in centimeter. Or say unit and then say centimeter. Or in the vicinity of the drawings, say that unit is centimeter. Yes. Dear CVE students, civil engineering students, that is my method. Okay. In Inventor, I'm going to answer the question in Inventor how you can show the dimensions in centimeter. Well, one of the video records, it is going to be the question, and you're going to find the answer. Okay. Turn back to here, and then dimensioning configuration is okay, and then the rest show the dimensions. Okay, then. Well, for this object, there are not few but more dimensions to show. But here, to be able to finish this video record, otherwise it may be very long and very big in size, and may not upload it in YouTube environment. I'm going to show only some of the dimensions and say that, well, complete this exercise at home while showing the others. I'm going to show the characteristic ones to answer the question. If the distance is a vertical distance, how? If the horizontal, how? If it is an arc, how? If it is a circle, how? It is an angle, how? And if it is a functional dimension, what is the thing to do? I'm going to answer these questions. Okay, select first of all annotation tab. Okay, and here make an underlining. Parametric ribbon, you can find similar symbols, but these are in modern method to input the dimensions, not to show the dimensions. Well, it is not the drawing stage, it is the dimensioning stage. So do not select parametric, select annotation tab, and well, use the tools of dimensioning facility. Say this panel. We have power dimension tool, and for each different case, well, corresponding buttons. Which one is recommended? Using power dimensioning tool, well, there is such a trick. If the dimension is a linear distance, then there is no trick. Click on this and show the limiting points of the feature. But if the dimension is an angle or radius or diameter, then after clicking on this, you must press enter. Clicking on enter may be forgotten. It is a trick. So, if you say that, hocam, I may forgot such a trick, then can say that, okay, then use these tools. If the distance to show is a horizontal distance, clicked on this button. If it is vertical distance, clicked on this. If it's an inclined distance, clicked on this. If it is a diameter, clicked on this. If it's a radius, this one. If it is an angle, that one. Okay? Yes. I'm going to, I can keep the notice in my mind, so I'm going to click on power dimension. And then see the rest. After clicking on that dimensioning facility or one of them in the other way, then pay attention. Now along the tab menu bar, I have a new tab, Power Dimension tab. And well, along the ribbon, what I have, since I selected for the measure of the non-functional dimensions precision is 0, yes, the selected primary precision number is written over here, 0 precision. Okay, and then the rest at this stage. Well, for instance, show the what the depth of the object. I selected as the suitable projection plane the left side primary profile picture plane, and on this view I'm going to show. Of course, to be able to indicate the terminal points of the features, well, use snap facility. Well, already toggled on snap enabling button, and then, well, need to indicate the endpoints. Okay, so enable the software, check it for indicating endpoints, and then, well, indicate this endpoint. Well, I made a wrong click, so do it again. Press escape button, and then, yes, I enabled the software to indicate endpoints. Indicate this, yes, snapping using snap facility. I brought the cursor to the vicinity, click, and then bring the cursor to the other limiting point of the feature, clicked, and then, you know, standard says that show the dimensions not over but outside. So move the cursor to the outside, to the vicinity. Now, you know, you remember during the configuration we selected 10 millimeters as the space to leave between the outmost boundary and the dimensioning line. How can understand that now this simulated extension and dimension line, say in the simulation the dimension line is 10 millimeters away? In AutoCAD it is the answer. Well, if the distance, well, after indicating the terminal points, move the cursor slowly away, outside. If the simulation is not in the color which you selected, it is going to be in the color which you selected for the dimensioning layer, eggplant color. Yes, in this example. But when the cursor is together with the dimension line which is in the simulation, reach to the place, now the distance is 10 millimeters, then there will be such highlighting and jumping, you see. While I'm moving the cursor slowly, then it is not under my control. The simulated dimension line jumped ahead. And now the extension and dimension lines are not in the color which I selected for dimensioning layer. It is in red color. So AutoCAD making such a changing, jumping and shifting the dimension line ahead and changing the line from another to the red, then notices us that the distance is 10 millimeters. Shall you show the dimension minimum 10 millimeters away? If yes, then the rest. Make a click. That is it. And then in AutoCAD, after making such a click, then the measured distance, of course, at the background multiplied by the inverse of the scale factor, and the indicated number is not the dimension of the projection, it is the dimension of the feature, dimension of the object. It is under say editing construction edit mode. Well, have a look at the dimension is correct. It is in the correct order. No mistake in the drawing. Then this means it is okay. Press enter. And then have a look at. You see, at the beginning of extension line we have 2 mm space. At the end of the extension line, after the tip of the termination symbol, we have further extension. Well, between the dimension number and the dimension line there is 1 mm empty space for underlining purpose. Dimensioning arrows, termination symbols are perfect. Okay. Font height for the dimension is in the correct order. All the things are perfect. Okay. Yes. If dimensioning configuration is correct, then the dimensions will be in accordance with the format requirements. Okay, then indicate some other dimensions if well, you have some others. Well, on the top view I decided to show this dimension. Say, well, front view from here to there. Click and then move the cursor away. Yes, 10 mm away. And then make a click. 55. Good. Okay, and on the top view I'm going to show the location dimension for the semi-cylinders with respect to here, from here to there. Okay. Move the cursor away, 10 mm. And then the location dimension with respect to this datum, I'm going to use not chain dimensioning but datum dimensioning for indicating the location dimension for the other semi-cylindrical extension. Well, located over here, 95. And if you have some others, then continue showing. Okay. And then press escape button. After showing the ones, these are to be shown in the horizontal direction. Assume that I show all the other dimensions, necessary ones. And then now select power dimension option, or if you say that yeah, I may forgot the trick, then select the tool option from this part of the panel, vertical dimension, power dimension, or this one. Power dimension is not recommended if you say that hocam I may forgot to click on enter key. When the enter key is to be clicked after starting the dimensioning stage, if the entity is a circle or circle arc or angle, you must press enter. But if you say that I may forgot to press enter, then well, use these tools. Vertical distance, I started process, and then from here to there, distance 30. If the dimension is correct, then okay, press enter and then continue. But here I'm going to use this scenario. Well, pity. It is 30, yes, but it would be 32. Why it is not 32 but 30? Because, well, assume I made a mistake at the transfer line creation stage. Using parallel with full distance facility, instead of writing 32, by mistake I wrote 30. So, well, the projection is wrong in size. If the front view is wrong in size, since the front view and the left side view, both of them use the same coordinate axis, z-axis between them, well, if the front view is wrong in size, then this means left side view also is wrong in size. In two-dimensional AutoCAD drawing or in hand drafting, such a case, correcting the mistake is little, say, really a time-consuming thing. Delete the wrong transfer lines in hand drafting, find them and erase, and then redraw this part of the projection on the front view and also on the left side view. Making for such a dimension, even one wrong dimension, making such corrections may take in the order of 10 minutes or more minutes. Well, considering the difficulty of making such a correction, well, there is an allowance. It is valuable in AutoCAD and also it was valuable in hand drafting. What is that? Replace the wrong dimension, although projection is still in wrong in size, with the correct value, but in doing this don't forget to underline it. Okay, then see how. First press backspace button. It is to say that erase. It is the thing to do. Clicked on backspace button of the keyboard. I said that don't show this dimension, and then write the correct value 32 using keyboard, and then to be able to have the dimension as underlined, clicked on this facility button. Not to scale, say that the dimension is distance is wrong but the dimension is correct. Clicking on this button, you can have the replace dimension with the necessary underline, and then press enter. And then zoom in. Yes, you see under the dimension we have an underline. Whenever you see an underline under a dimension, then this means projection is wrong in size, but the dimension which has been shown is correct. Yes. Clear, I think. And then continue some other dimensions. Well, distance from here to the axis of the semi-cylinder. Yes. Show this dimension 75. Okay. Press escape button, and then, well, since I forgot this smaller distance first and then the larger distance, you know, if I indicate this distance over here, then the space between the dimension line and the boundary of the projection won't be 10 millimeters. If I indicate it over there, then it is going to be a violation, because rule says that avoid having intersections along dimension lines. This is really a poor practice. Show the shorter distances first and larger distances later. What can you do? If you forgot to show a smaller distance first, what can you do? Well, okay, don't be in a panic. Well, first make a click on the dimension it is in a greater size. After the click, you find the gripping point just on the dimension. Hold this gripping point and then slide. You can make the distance greater. In bringing the selected dimension line together with the dimension to another place, I recommend disable snap facility, because while the cursor is in the vicinity of a characteristic point, that characteristic point may snap the cursor. So instead of locating that dimension at a suitable place, it may find its place at a wrong location. Okay, well, after locating this dimension here, press escape button and select the other, and then, well, make the distance between this and the boundary in the recommended order. And then, well, this distance is too much, then, well, select and then make it closer. Yes, you can make such editings. It's possible. Okay. And then now, well, radial distances, radius. If you selected power dimension, then, well, don't forget to click on enter key and then can indicate arc. Yes, now AutoCAD can understand that it is the radius. It's a circle arc, so we show the radius. Yes, and then show the radius, find preferably a space between the views and show the dimension over there. Okay, as inclined, not horizontal, not vertical, but inclined. And you know the convention. For showing radii and diameters, we omit the extension lines. Press enter. Or if you say that hocam I may forgot clicking on enter key, then well, select this facility, clicked on this and then show the entity. Well, for this drill I'm going to use dimensioning technique. Clicked on diameter button or power dimension, press enter and indicate the circle. Well, since this is a crowded region, well, may show it over here, but there, if the space is sufficiently large to show this dimension without any clash, show it preferably between the views. You know the reason, because z-axis is commonly used. Okay, press escape button. Okay, on the top view, power dimension or clicked on reduce indication button, which one you like. If you selected power dimension option, don't forget to click on enter key. Indicate the circle and on the top you say that 30 millimeters. Press enter. Okay. If you have some others, then continue indicating the other circle arcs and then press escape button. And now, well, it is now finally the time to talk about in the classification the meaning of reference dimensions. Already talked about what is functional dimension, what is non-functional dimension, which one is functional entity, non-functional entity, but said that during the CAD application in demonstrated things, I'm going to educate you on the meaning of reference dimension. Well, this notice in the parentheses is important, but I need to explain what does it mean. First of all, reference dimension is overall height or overall width and or overall depth. But not in all the cases. Well, explain. First, inform you on this convention. To be able to provide the size info, overall size info for the interest of reader, it is under agreement and it is our convention. We show overall height, overall width, overall depth of objects. Overall dimensions, height, width, depth values are not optional. Show them always. Okay? For instance, here on this view, show the overall height. It extends, snap enabling of course, from here to this tip point. And then show this dimension, 100. It is the overall height, but you see here there is a mathematical fact. Can you see? 75 is the distance from the bottom side to the axis of the semi-cylinder, and we show that dimension because it is necessary. It is the location dimension for the semi-cylindrical features. It must be shown. The rest, you see, radius of semi-cylinder has been shown 25. So mathematically obvious, 75 plus 25 makes 100. So someone may say that, yeah, well, since 75 plus 25 makes 100, no need to show the overall height. Reader can make such a calculation, 75 plus 25. Yes, although it is possible, but in our tradition, in our convention, height is not optional. always it is to be shown. But here, since 75 plus 25 makes adding the other indicated dimensions can find the overall height, then in this case, since it is so, overall height is a reference dimension. And what does it mean? Reference, if it is reference dimension, overall height may be reference dimension, overall width may be reference dimension, overall depth may be reference dimension. In which case, whenever the overall size can be computed by adding the other dimensions which have been shown on the projection, then say that it is reference dimension. Well, the value of making a highlighting that it is a reference dimension is that to be able to find the upper limit, lower limit for the reference dimension, overall dimension, well, this is the thing to do. For 75 determine upper limit, for 25 determine upper limit, and add the upper limits of those dimensions and find the result. Say that the result is the upper limit for the overall height. Determine the lower limit of 75, lower limit for 75, determine lower limit for 25, and then add them up. The result is the lower limit for the overall height. For overall height, never refer to tolerance table, because overall height in our case can be computed adding 75, adding 25. 75 and 25. So in determining the upper lower limits of overall dimension, add the upper lower limits of the constitutive dimensions. 75 and 25 are constitutive dimensions. Just to notice the technicians to say that for 100 millimeter overall height, such a case, don't refer to tolerance table for finding upper lower limits. Determine upper lower limit for this dimension by adding upper limit of 75, upper limit of 25, lower limit of 75, lower limit of 25. Show this dimension between parentheses. Yes, reference dimensions are shown between parentheses. How you can show this dimension between parentheses? If it is reference dimension, of course, clicking on this button, reference dimension facility. Yes, and then press enter. You see now it is in the parentheses. I hope you understood. Well, here depth. Depth is overall size 60, but don't show it between parentheses, because, well, the other dimensions not shown, and other to add to find 60. So 60 is overall dimension, but it is not reference dimension. But here 100 is overall size, but also it is reference dimension, because 75 plus 25 is equal to this distance. Clear writing. How about angles? Answer the question. Power dimension, if you're going to use this facility, click and don't forget to press enter. And then indicate the raise. But if you say that, hocam, I may forgot to click enter key, so for such students, I address this button. Okay? Clicked on this button and then the rest. Indicate the raise. Indicate this line, indicate that line, and say that the angle between them is a necessary dimension. Move the cursor away and then locate it with a click. Press enter. That is it. Press escape button. And of course, for this example, say for this object, we have some other dimensions. These are to be shown. For instance, thickness of this ear, thickness of that ear, thickness of this strengthening flex. These are also necessary dimensions. Here the size of the channel. Okay. Show it. Reduce. Indicated. 20. It can be shown here. It is non-functional. If yes, then okay, press enter. But if it is functional, show it with the necessary IT grade. Well, here I'm going to say that not this, but the width of the channel, it extends from here to there, is functional. And then demonstrate how a functional dimension can be shown. These are non-functional dimensions. To be able to determine their upper lower limits, you know, at the title block, the tolerance class, letter is C, coarse, and refer to the tolerance table. Here is the tolerance table, and then if the class is coarse, then what is the deviation, and then the limiting values. Well, previous video records, I sufficiently talked about such things. Okay. Before focusing your attention to the functional feature and the thing to do for showing a functional dimension, then, well, here, remind you, well, the holes are, the specifications of holes are shown using annotation technique. Well, dimensioning my presentation and then find the part. It is not for the first time. Remember, already talked about the representation annotations for the hole. Simple hole this, a blind hole that, contour bore hole this, countersink hole that. Yes, well, it is quite common annotation. Yes, there is a contour bore hole in the design of this object. Here it is. It is truly extending, and you know, it is size. Well, from the model, well, call the memory, the bore diameter 30, drill diameter 20, and the distance from here to there, it is the bore depth of bore is 10. Okay, and then in AutoCAD, see how such an annotation can be shown. Actually, already answered such a question talking about text facility of software. Leader node is the answer. Clicked on this button, okay, to have an annotation. Find the image where see the edge of the hole. It is the top view in our example, and indicate the edge of the hole with a click, and then move the cursor away. Minimum 10 millimeters away till you reach to such a point. Move the cursor. You know, leader line should have an inclined portion and horizontal tail. So don't move the cursor vertically, don't move the cursor horizontally. In the inclined direction, move it. And then after reaching to the empty place to show the annotation using an inclined leader line, make a click and then right click. After right clicking, cursor will start to blink over there and find the leader node ribbon. For leader nodes, AutoCAD uses a different layer, not text layer, different layer. Already configured text layer, but say this layer not yet. Well, clicked on this listing arrow, and well, I decided to show the leader node again in the eggplant color or brown eggplant color. I selected this color option. Font height, well, already configured text facility, but here as the number here, do not select font height. Multiply the recommended font height by the inverse of scale factor. Scale factor in this example is 1 to 1. Inverse of 1 to 1 is 1. So 1 times 5 is 5. So select 5. And then the rest. Write the annotation. First have the diameter symbol. This is the listing arrow to drop the list of the commonly used symbols. One of them diameter. Or here along this row can find the most commonly used symbols. This or this or lastly used ones. Drop the list of the symbols, bring this table with a click, and then select diameter option. And then write the drill diameter. I know it is 20, comma. And then from the list select contour bore symbol. to say that at the entrance there is a contour bore. Diameter symbol. Well, diameter symbol. Yes. And then diameter of the contour bore, it is 30. Clicked on comma key. Depth symbol. Yes, here is the depth symbol. And then the depth of the contour bore, 10. And then say OK. Clicked on close editor button. Here is the annotation. Actually, still continue taking the risk because I forgot to save the file. During the exam, especially, never make such a mistake. After the text configuration stage, make say one more time, save the file. So, well, saying by the way, okay, I'm going to save the file, save as. Okay, show the address. Although you selected save as option but couldn't find save dialog box, you know, this means you need to press escape button first and then write this command, file dia, to shoot the trouble. It was one of the exam questions last Sunday, you know, during the midterm exam. Okay, but it is okay in my case. No need to write file da command. Okay, in the dialog box, say that surname first, ID number, and then section number, etc. Well, this classwork is about dimensioning. I said dim or dimension, dimensions. Date of today, say that 19th of May. May 19. Okay. And then before ending this video record, say that, well, you learned the necessary things about dimensioning in AutoCAD. But for civil engineering students, well, there are some complementary things in other video records. I'm going to talk about a few more things additionally as complementary. Well, finally, focus the attention to functional feature, and it is dimension. In the scenario, in this example, what I say, the distance, okay, yeah, from this profile surface to the opposite profile surface is functional because, well, this object is to be mated onto a guide, and, well, over the guide, this is to reciprocate. Imagine, so it is going to be in contact with a solid feature, so its dimension is functional. Show how. Start the dimensioning process, clicking on power dimension or this one. Okay, and then show the limiting points. Click, and then move the cursor. Yes. Normally, AutoCAD, using its default configuration, will show it as a non-functional, as if. But it is functional dimension, so, well, see how. Old-fashioned format, old-fashioned. If you're going to show the functional dimension using old format, in old format, write the nominal value and deviation values. Then clicked on this button. Although today only few companies may be the ones still using old format. Why still they are using old format, dimensioning format? Because decision makers, senior engineers in the company are old men, so they couldn't follow the up-to-date things. They couldn't follow the literature, new version of the standard, so they are keen on using the old format. Maybe the case, so, well, educate you how. If you're going to show the dimensions not by using IT tolerance grades but writing the deviation values, make a selection on this option, tolerance option. And after this click, yes, AutoCAD understood that you're going to show the dimension in the old format. Okay, into these boxes, write the deviation value. Say that the deviation value for this dimension, positive, write plus, 0 point, deviation starts from tenths. So say that, for instance, 2, and the other figure is 5. Although you see I typed the deviation value, here in the simulation it is still 0. Why? I'm going to answer this question in a few seconds. Lower deviation, say that negative 0 point, let's say 0, 1 is the lower deviation. Why still I have zeros here, although I use 2 figures? Because of that reason, expand this panel, clicking on this arrow, and then for the deviation values, increase the precision by clicking on this arrow. 1 precision, 2 figures. Okay? Well, need to show the deviation using 2 figures in this example, say, I know. So, clicking on this list arrow at the expanded part of the panel, increase the precision for the deviations by 2. So start seeing the deviations over there, and then clicked on close button. If the deviation value for the other started from hundreds, say that this is also a space holder, then need to show this dimension not integer but decimal number. In AutoCAD, to be able to, for the other ones, non-functional dimensions, we check that deviations are almost all start from tenths. So during the dimensioning configuration stage, we selected 0 precision. But here need to show this dimension as not integer but decimal number. In AutoCAD, to be able to take a right to show the number as decimal number, first here into this box, write the precision value as not 0 but 1. Because at the decimal part, need to use 1 figure. Okay? And then bring the cursor to here, click. It is not automatic. Manually make a click after 60. Put the dot, and then write the first figure. What is the first figure? In this example, let's say it is 1, or 0, or 2, or 3, or 5, 4, 7, 8, or 9. It is determined by the designer. And then say close. Yes, now in the old format, this is the thing to do or to know for functional dimensions. Clear, I think. Okay. Save the file with a different name. Save as dimension. Instead of saying dimension, say that functional dimension old format. And then how about the format of today? And in the format of today, what is the thing to do? I'm going to edit this dimension. How? Double clicking. Yes, I took this dimension in edit mode. Do not click on tolerance tab. Click on fit tab. Okay, now when AutoCAD understood that, show the functional dimension in the format of today. AutoCAD automatically selects an IT grade using its default configuration. This is just the arbitrarily selected IT grade. Well, here, to be able to select the IT grade, the thing to do is that bring the cursor onto this listing arrow, click on the arrow, and then find this dialog box, fit dialog box. Make a click on this phrase. It is to bring the dialog box to select the IT grade. Well, this is the dimension of an empty space. You know, you learned already, I educated you. Showing the IT tolerance grade for feminine features, we use capital letter. So, well, do not select shaft option. Shaft, as an example, means muscular feature. If it were the size of an extension, then I would select shaft option and find the lowercase letters in this column, because IT grades of muscular features are shown using lowercase letters. Yes. But since this is a channel empty space, then make the grade letter selection from whole, selecting whole option, and from this list, all the letters you see, well, A, B, C, D, and the combination of some letters Z, A, Z, B, Z, C are all the letters in IT tolerance grade system. Say that in our example, the selected IT grade, well, how? By the designer. What is the measure? You know, we have in this table recommended IT grades. For instance, the mating is to be close running fit. So H8 is the recommended IT grade. Okay, then H8. So from this list select H, and from the other list IT grade number 8. After making this selection, then we'll see the magic. AutoCAD in this pane in the dialog box will show the calculated values. Upper deviation 0.046, lower deviation 0. So upper limit 60.046, lower limit 60. Since the deviation starts from hundreds, yes, similarly here we need to show the integer, say the nominal value, not as integer but decimal. And in this example it is 1, 60.1, 60.1. Okay, and then say okay. And then you know the good practice. If your technicians cannot convert H8 to the upper lower limits or deviations, not in AutoCAD, but in Inventor, it is possible to show the upper lower limits between the parentheses. You know this recommendation, showing the dimensions. Yes. Here in the parentheses show the upper lower deviations. In AutoCAD you can do it, but preferably show the limiting values, because technician may make a mistake adding 30 and this one up. Show the limiting values, but in AutoCAD impossible to show the limiting values, can show the deviations. Well, here actually I made a wrong click probably, and since I am in the process, okay, continue. Well, here okay, press escape button first, maximize this dialog, say this window, and then well, do it again, edit, okay, clicked on this listing, select not this one, toggle it off, toggle on this, toggle it on this one, and then well, to teach to the software that not H6 but other IT grade you're going to use, clicked on this listing arrow, fit dialog box, click, and in this dialog box make the selection from the correct option, correct list. It's an empty space, so I selected whole option, and then IT grade letter is H, IT grade number is 8, and then I said OK. And then the good practice, clicked on this listing arrow, And then for enabling your technician to see not only the IT grade but also the corresponding deviation values, not limiting values but deviation values. Well, here actually it is possible. Try to use this option. Yes, it is possible. No, well, it is in the old format. Sorry, not this one. That one. Okay, can show the deviations in the parentheses. Select this one and then say OK, close editor. Yes, well, here it is written upper deviation, lower deviation, and IT grade is H8. Yes, dear students, well, try to do my best in answering the questions, how the dimensions are shown. Well, one more thing finally. Well, if you're in the case, say, well, at the beginning in AutoCAD, it is recommended, considering how many dimensional rows you're going to have, then have the space between the views sufficiently large at the transfer line creation stage. But if you couldn't foresee that you will show one more dimension or few more dimensions, so at the beginning made a mistake and couldn't have the space sufficiently large, what can you do? For instance, here, when you attempt to show some other dimensions, okay, well, from here to there, show this dimension. Okay, not of course as functional, toggle off the tolerance button. Okay, press enter. And then, well, overall height, overall width is to be shown, but you see, well, I have no space to show one more dimension. What can I do? Well, tedious case. Press escape button and then, well, moving the projections in the vertical and also in the horizontal direction. Make the space larger. You know the format requirement. If the space between front and the top is equal to A millimeters, between the front and the left, it should be in the same order, A millimeters. If you increase the distance between this and that, then don't forget to increase the distance between the others. This and the other. Well, in doing this, well, answer the question how. First, don't forget to ask the visibility of all the layers, because now it is just simply a moving issue. Move the views, okay, to new locations. Not only the views, but the associated lines as well, construction and transfer lines. So if the content of all the layers are in the screen, then you can apply move process for all. And then start the move process. Clicked on move and then using windowing method, select those views. Okay, or yes, I think this is better. Top view. I'm going to show, say, move the top view. But the other format requirement, you see, this space should be comparable with that space. So move the front view, left side view a little bit away toward the upper margin. Move the top side view a little bit away in the down direction. Well, time consuming thing. Okay, move process. Okay, select left side view, front side view using windowing method. Press enter. And then as the base point, select this point. Okay, and then move the selected things in the vertical direction. For my convenience, I'm going to select ortho facility and then, well, show the new location for the base point. Into the first box. Yes, second box, sorry. Right delta x value. Since I need to move the selected ones in the vertical direction, not in the horizontal direction, the abscissa value, delta x value, is equal to 0. Clicked on comma key. Ordinate value, delta y. Since it is in the up direction, you know, delta y is in the positive sense of the y-axis. Write delta y as positive. How many millimeters need to move the selected views in the up direction? Say that 5 millimeters. Or for being safety side, 10 millimeters. Okay. Press enter. Yes, now these are 10 millimeters at a higher level. Well, if you move the front and the top views 10 millimeters, then well, move the top view 10 millimeters in the down direction. So one more time, start the move process. Okay, and then select the, well, here doing this, be careful. Do not select title block. Well, select the view. If title block is very close and say you're in difficulty in selecting the view, then take the visibility of title block, making a filtering. Then it cannot be selected. I selected top view, press enter, and then base point, indicate this point as the base point, for instance, and for this point write delta x, delta y. Into the second box, delta x value. I don't want to move it in the horizontal direction. Write it so as 0. Delta x 0. Clicked on comma key. Delta y 10 millimeters. But since this displacement in the negative direction of the y-axis, write it -10 and press enter. Press escape button. Okay. And then after making the space between front and the top 20 millimeters greater, then don't forget to make the space between the front and the left 20 millimeters. So well, one more time move process. You see, AutoCAD is an old-fashioned software, and well, these are, if at the beginning couldn't calculate the space value sufficiently large, then well, when you see that the space is not sufficient to show some other dimensions, you see, well, applying move process, yes, you can make the space larger, but it requires a time. Okay, move process one more time, and then now I'm going to move the left side view. I selected those, press enter, and then I'm going to move the left side view, just indicating this point as the base point for which I'm going to write the coordinates. Okay, into the second box, delta x, in that case write well, 10 millimeters. Well, actually I made a mistake. Wrong click, press escape button and restart it. Move process, start move process, indicate the view, press enter, indicate the base point, and then into the second box write delta x value. Since the displacement is to be well, in the horizontal direction and it is in the positive sense, write delta x value as positive. Clicked on comma key, delta y value as equal to 0. Press enter. So on and so forth. And then take the visibility of transfer lines, and then you see, manage to have more space, then show the total width. Annotation, width value from here to there, show the dimension. But here this dimension, similar to the height, is reference dimension. Why? Because 145 plus 30 is equal to the overall width. To say that for the overall width, don't refer to tolerance table. To find its upper lower limits, find the upper limit for 145, upper limit for 30, and add them up. For the lower limits, similarly, lower limit of this plus lower limit of that is equal to the lower limit of this dimension. Show this dimension between the parentheses. Clicking on this button, you can take the dimension into parentheses. Close, and then, well, really say that you learn the necessary things about dimensioning and dimensioning configuration in AutoCAD, and then can end this classwork saying, my dear students, bye bye. The next video record will be to demonstrate the things similarly in Inventor. Okay, see you then. Stop the record.